Gravity and friction, keeping things in order. Let's try. Raise your right hand in front of you, then place a book on the palm of your right hand. Do this for 1 minute. How does it feel after 1 minute? Next, apply powder on your hand and rub it. Then, try to grip a pencil or ball pen. Is it easy to hold on or is it slippery? The two activities that you did explains gravity and friction. Gravity and friction are two naturally occurring forces. Let's talk about gravity. Anything that is thrown upward falls down. Gravity is the force that pulls objects toward the ground. Falling objects are examples of accelerated motion due to the force of gravity. Gravity and mass. Anything that goes up ultimately goes down. Things do not fly on Earth's surface. This is because Earth is exerting a strong attractive force on you and the things around you. This force is called the gravity. Sir Isaac Newton was the scientist who discovered the principle of gravity. According to this principle, everything in the universe, whether big or small, exerts gravity on other things. Since Earth is massive, it strongly attracts anything on its surface. The same concept keeps the planets and other heavenly bodies in place. Since the Sun is more massive than all the planets, their gravity pulls them into around its orbit. Gravity and weight. The gravitational force exerted by the Earth on an object is equivalent to the object's weight. The greater mass an object has, the greater its weight. Heavier objects like the blackboards in your classroom and the appliances in your house weigh more than lighter objects such as books and pens. Gravity and distance. Gravity is a non-contact force. It acts between objects even if they are separated and far from each other. The farther two objects are from each other, the smaller the gravitational pull will be between them. Astronauts in space stations and spacecrafts can float around and do the spacewalk. They are not weightless. They still have weight, but since they are far from Earth, it is less than when they are on the ground. Let's have another activity. Drop a sheet of paper and a crumpled paper at the same time. Observe the objects. What happened when you dropped the crumpled paper and the flat sheet of paper? Which of the papers reached the floor first? Why? Why is that a sheet of paper falls more slowly than a crumpled one? Have you seen a parachute? Can you describe its movement? Why does a parachute move slowly? In your activity on the falling papers shows that air resistance affects the movement of falling objects. The sheet of paper falls slowly because of air resistance. The surface area of the sheet of paper is affected by the air and causes it to drop slowly. The crumpled paper has a smaller surface area, which is not affected by air, so it moves faster. The greater is the surface area of the falling object, the greater is the air resistance that affects its movement. This concept is similar to parachute. The parachute falls slowly because of air resistance, so it gives the assurance that the person using it will land safely. Its umbrella-shaped canopy reduces the speed of a falling object or person. This is why parachutes are used as life-saving devices for skydivers, balloonists, pilots, and passengers of aircrafts. What happens when a falling person does not use parachute? Without a parachute, the skydiver will move downward at 32 feet or 9.75 meters per second. That is, with each second of fall, the skydiver or any falling object is moving at a velocity of 32 feet per second, and at the end of 2 seconds, 64 feet or 19.5 per second, and so on. which is very dangerous. At this rate, do you think he will survive the fall? Therefore, he needs the force of air resistance to drop more slowly, so he needs a parachute to save his life. Space exploration. Scientists discovered that the force of gravity varies with the distance from Earth. A rocket must lift off fast enough to overcome the force of gravity. It must accelerate at about 40,200 kilometers per hour to escape Earth's gravity. This speed is called escape velocity.